In this video, we're going to show you how to actually solve for the voltage required to saturate a transistor. Here we have just a slightly altered transistor circuit. Notice that we don't have any resistance at the emitter, but that is all right. So first of all, we're going to designate some values here at the resistances, and at the voltage source. We're going to go to Excel here, and we're going to set the voltage source to be at 5 volts, and the resistance at the base to be 500 ohms. The resistance at the emitter is going to be 0 because there is no resistor. And the resistance at the collector, we're going to lower it down to 200 ohms. And the resistor going from the base to the emitter is, again, generally 0.7. And the resistance going from the collector to the emitter is generally 0.2. Okay. And now we can solve for the Vn required. Again, let's take a look at this equation right here. Let's go ahead and copy that and paste it right there so we have a good reference. So that is going to be equal to the voltage drop right there plus parentheses for the numerator, the RB plus RE times 1 plus beta. Oops, forgot beta. We'll put it right there. And let's set beta equal to 100. Huh. I don't think it likes something from that. C5, C7, C8, C10. I forgot the multiplication. Alright. Excel lessons for us all. There we go. So then we're going to divide that by beta times RC and add it to RE times 1 plus beta. And then close the numerator, parentheses, denominator. And then we're going to multiply that whole fraction by the difference between the voltage source minus the voltage at the voltage drop from the collector to the emitter. Enter. And we need a signal of 0.82 volts in order to get our transistor totally saturated and allow all that electrical current flow through. Since we've got this equation already set up, let's go ahead and change some of these numbers. So if we were to have a high resistance right there and a low resistance right there, let's see how that will change things up. So let's go ahead and switch these around. We'll set this to 200. Oh. 200. That to 500. Oh, I'm sorry. Let's set this to 1000. That'll be at 500. So if we set this to 1000, that'll greatly increase, or it will increase the voltage required to saturate that transistor. And it's interesting that the lower the resistor at the collector, it also increases the voltage required to saturate the transistor. beta, increasing it will decrease it, mostly because we will get a much steeper slope if we increase beta, and if we decrease it, you'll get a much not as steep slope, which will increase the voltage in required to saturate our transistor. And the voltage source in, if we increase that, will also increase the voltage in required to saturate. And that is about it.